Hello, everyone. Welcome to today's webinar, Applying AI in Supply Chain Planning, Practical Gains versus Unrealistic Promises. My name is Kristen Tiley, and I'm the Director of Marketing here at Arkiva, and I will be your moderator today. Discussing the topic is Sujit Singh, COO here at Arkiva. Sujit, can you quickly introduce yourself?
Yes, hey, thank you, Kristen. Yes, great to be here. These days, AI is such a hot topic. I'm happy to present some of my thoughts on it.
Great. We have a few announcements before we begin. If at any point you have trouble hearing us, please let us know using the chat feature and we'll be sure to assist you. We do have a few polling questions in today's session, so be sure to respond to those when they come up. And there will be time at the end for questions, and you may submit an online question at any point using the questions window. Now, before I hand things over to Sujit, I'd like to share a little bit about Arkiva. For more than 30 years, Arkiva has helped global enterprises drive business transformation through improved supply chain processes. Recognized by Gartner and the Gartner Supply Chain Planning Solutions Magic Quadrant, everything we do is aimed at solving complex planning challenges and creating cutting-edge technology that enables you to run your business at peak performance. We continually challenge ourselves to create solutions that not only solve today's problems, but future problems as well. We live in a dynamic world where speed, accuracy, and efficiency are critical to drive business transformation, and we believe that starts with better planning. Our goal is to enable your business to benefit and thrive from the way our solutions unlock the true value of your supply chain. Our fully integrated S&OP solution is a demand-driven business planning process that promotes cross-functional synchronization within the company, starting from integrated financial planning to demand and inventory management to create a more dynamic S&OP management process using real-time dashboards. And with that introduction, I'll hand things over.
Thank you, Kristen. All right, so let's jump into the topic today. As I walk through, we'll talk a little bit about what AI/ML is. We'll describe a little bit in terms of traditional versus emerging AI, because believe it or not, AI has been in use for quite some time. That may be news to some. And then the three main areas of AI: predictive, generative, and agentic. We'll talk about that. We'll talk about how it can be used in things like scenario planning, which is important to deal with uncertainty. And then we'll conclude. Now, obviously, we are not going to get into the nitty-gritty and the mathematics of AI. So we'll keep it generally high level, and we'll focus the whole discussion past the initial orientation slides with how AI works in the field of supply chain. All right, so let's get started. So we wanted to kind of ask the question to AI itself, what it felt about the question of what AI's role is in the world of supply chain. So in order to do that, we have asked AI to generate a video explaining what AI looks like in the field of supply chain. So let's play that video.
Ever wonder how your favorite products always seem to be in stock? It's the intricate dance of the supply chain. For years, this dance was a challenge. Then, artificial intelligence stepped in. So what is AI in supply chain planning? Imagine your supply chain has a super smart oracle, always learning, always predicting. AI, or artificial intelligence, is that oracle. It uses machine learning and predictive analytics to make sense of vast data, helping businesses make smarter decisions. We've moved from reacting to forecasting. Old methods relied on guesswork and spreadsheets. Now, AI looks forward, analyzing trends, social media, even weather, to predict demand with incredible accuracy. How does this oracle work its magic? Demand forecasting AI predicts what people will buy, when and where. Less waste, fewer empty shelves. Inventory optimization. AI calculates the perfect stock levels, cutting costs and preventing stockouts. Think Amazon's perfectly orchestrated warehouses. Logistics and route optimization. AI maps the fastest delivery routes, avoiding traffic and reducing fuel. Risk management. AI spots potential disruptions, a port strike, a natural disaster, before they hit, letting companies adapt. But here's where it gets really exciting. Imagine an AI supply chain co-pilot that not only predicts but autonomously acts. Self-healing supply chains that detect problems and reroute orders automatically. Or AI simulating countless what-if scenarios, making our global supply chains truly unbreakable. AI isn't just a tool. It's transforming the chaotic supply chain dance into a ballet of precision. It's empowering the supply chain to not just react but to predict the future. And that's a future we can all look forward to.
All right, so there you have it. AI talking about AI. Hopefully you could watch the video, and hopefully the volume was coming through. That is an excellent example of AI at work. In fact, it's an example of generative AI at work where it has generated a video for us. We could declare the webinar over because AI has spoken, but we'll not do so. We'll keep going with the rest of the material. So what is AI is the first question. So when we say AI, what is implied is that we will use some technologies to mimic cognitive functions, brain functions associated with human. So in terms of try to replicate how humans think and make decisions. And the most common version of that is generally referred to as AI, is just the plain artificial intelligence, which is very geared towards specific jobs, specific tasks. And then you can have a more general intelligence, the same way a human mind can solve many different types of problems. So that would fall under the category of general intelligence. It is generally agreed that we have not reached that stage yet, although we are working towards it. And then last but not the least is artificial superintelligence, where the idea is that not only will we match human capabilities in terms of making decisions and thinking and reasoning, we'll go beyond it into superintelligence, where one computer program will be equivalent to 10, maybe 100 humans. That's where people get really scared about what this technology is going to bring. Neither of these, the AGI and ASI, are here today. Practitioners will tell you we are racing towards it. Non-practitioners will probably doubt it, and truth is probably somewhere in the middle. Let's also define machine learning. Machine learning is a subset of our AI. So AI is the broader field. Machine learning is a subfield where it basically enables a machine or a system to learn and improve from experience and or data. So if you think about ML as an application of AI, that's one thing, but also because AI is supposed to replicate cognitive capabilities of human, it does deploy ML to learn as new data comes in. So, it goes back and forth between the two, and just understanding it in a flexible way is the way to go. All right, so here I want to begin with kind of explanation of where I think we are. And here's a graph that I got from a very good speaker that I heard at the Gartner conference, Peter Hinson. And he was describing that anytime there's a new technology, there's always an early phase where the expectation is outpacing the actual delivery from that technology. And then you reach some kind of an inflection point beyond which the technology delivers more than the expectation. And then, of course, around that same inflection point, people begin to think of these new technologies as the new normal. We kind of anticipate and expect that new technology to deliver. So he talked about this technology, this particular S curve in the example he used was digital. So in the beginning, everything digital was seen as innovative, and there came a point where digital became the norm. And so with any new technology, this is the type of curve that happens. In the beginning, humans are disappointed because human expectation is outpacing what is actually coming out. And then eventually it becomes the norm, number one, and number two, it does outpace the human expectation. For example, with digital, one could argue the COVID years was where the inflection point happened somewhere in there, and now we do a lot more with digital and just expect it to be the norm. If you do Teams meetings, for example, it's not that they were not there before, but we reached that inflection point in there somewhere where a majority of our business is now done through that remote technology. So with respect to this idea, when things will become the norm, I want to just flag a couple of examples and then also talk a little bit about the AI's, the hype and so on. The examples I would say is, as AI becomes more and more part of our life, the expectation will be that it's just another technology. There's actually a paper by these authors, Arvind Narayanan and Sayash Kapoor, where they talk about AI as normal technology. And so the examples that they share are, for example, one day, cars would simply come to mean self-driving cars, and it will be the manual driven car that will be the expectation. Now, someday could be 5 years, could be 10, could be 15, but that would become the norm at some point because AI would become normal technology. As an example, similar example, today, if in your email box you have a whole bunch of communication with your customers, at some point the normal would be that the email program would evaluate all these emails and give you some quick summary as well as some sentiment score that could say, if you're dealing with, for example, a field of customer service, that this customer is needing attention as of this minute because they are unhappy about something, or if there's a trend line towards becoming unhappy or happy for that matter. So the way they write the paper, they say that these technologies will become normal and we would expect them to just do certain things for us. Same authors have written a very nice book, and here's a graphic from that book. The book is called The AI Snake Oil. So in that book, they warn about how AI can be done, can be, over sold, and you may get an expectation that is simply not possible, and in some cases harmful. So this is just a chart from them. If you look from left to right, they have benign technologies, they have harmful technologies all the way to the right. And then bottom to top, you have technologies that work today and technologies that might be simply being sold as snake oil. So I would highly recommend both the paper and the book, and just say that, highlight a couple of examples. A benign might be when you type on your phone, it completes your words, and that's benign, or maybe completes the sentence, which is benign, and it works and it's good. Harmful could be facial recognition for mass surveillance. Technology is improving, it is working, it has come to a level that it was not there a few years ago, but obviously that can have societal harm. And then there are technologies that simply do not work. For example, there were companies that said that if you have a job candidate, ask them to submit a video recording of 30 seconds, and from that we will evaluate, the technology will evaluate character traits and other traits which would tell you if they were going to be a good hire or not. Well, work has suggested that those technologies, at least as of current moment, do not work, and so therefore they are describing it as snake oil. What is the main purpose of this slide? It's to say that as we use AI, let's be aware that some things work and can be useful, and some things are oversold, and let's steer clear of those. And especially if they are harmful, then by all means, let's not even think of using them. All right, so that is the background. Now let's talk about progression of AI in supply chain planning. If you look at, and as I was saying earlier, AI has been in use, believe it or not, for a long time. We just didn't call it AI. So in the old days, the techniques that were used were primarily towards decision support. The systems were there, they would pull the data, they will give you the insights, but the user or you would make the final call, make the final decision. Then it moved to augmentation, where the these AI tools were going further. They were suggesting actions based on patterns and predictions. And sometimes the user would make the decision, sometimes the user would accept the AI decision. They were working together. And then finally, we reach the stage of decision automation. AI makes the decision on its own with little or no human input. Now, this is the part where people get worried. You could argue that, especially if the technology is what the authors of the paper describe as snake oil, then it can be actually net negative to us and to the society. But certainly, the field has moved in this direction, and a lot of decisions are being automated through AI. And I think that is only going to increase, like my example of a self-driven car. So, since I said that the AI has been in use for a while, I was very pleased to find this graphic from Gartner, where they said that AI does not revolve around Gen AI. What is Gen AI? This is your Chat GPT or any of the large language models that exist today, Copilot, Chat GPT, Gamma, and so on. And so I took the liberty of drawing this line and I said, well, there are some things that are part of the traditional AI, have been in use for a while, and some things that are part of the emerging AI's toolkit. And so things like optimization and simulation, I'm sure folks on this call have heard and used those techniques for a long time. And your emerging AI is your Gen AI, your non-generative machine learning, and so on. So let's spend a little bit of time on these things. So when we think about traditional AI, let's talk about the three areas that I highlighted. Now, it's not limited to those three, but let's just talk about those because the Gartner graphic talked about them. So let's talk about optimization. The idea here is how to select the best option from a variety of combinatorial options, meaning you can combine different things in different ratios to get very different results. So here could be a supply chain problem. Let's say you have one main raw material, and let's say that goes into hundreds of products that you make. Supply of this raw material is rather limited, and so now you have to make some determination about how to apportion the supply of these materials into your products. Now, some products through the recipe use a lot of this raw material, some products use just a little bit. Then there's the added complication of the machines on which they can be made. Some products can be made very fast, others can only be made really slow. And the capacity on the machines itself is limited. Well, we are always limited by time. So at the most, a machine can run 24/7 if you run it full time. And if you have shifts, then you're limited in that way. And then to make things even more complex, you have a demand that may not follow anything along the lines of your recipe, your speed, and so on. So the demand ratios might be such that you need a lot of the really slow items and you may not need a whole lot of the very fast items, or vice versa. So given the demand and given these complexities, what is the best combination to run? Do you run the faster products? Do you run the slower products? Do you run the products that use a lot of the key raw material? Do you run a little bit of those materials that use the key raw material? The answer is, it depends on the mix of your demand. And how do you get to that answer? Well, you use a technique around optimization to get to that, which will evaluate the various different possibilities, various different combinations, and give you at least a mathematical best, which you can then evaluate in business terms and then use it. The other part of traditional AI toolkit is simulation. So given a network, given your supply chain network, you want to simulate the effects by changing the input data. So you may want to say, what happens if this factory is going to go down? What demand will be now left stranded? What if a particular customer orders too much? Their demand is way out of pattern. You may have questions about what if I randomly vary demand and see what percentage of time I stock out. So these are questions that can be handled using simulation. The types of simulation that we would do might be different, but we'll put that all generally in one area called simulation, which is also a part of the AI toolkit. And then, of course, you have rule-based and heuristics types of approaches for certain types of problems. Not all problems are suited for optimization or simulation. You may want to do your intelligence using simple rules. Rules may be developed in the beginning by humans, but then you can enhance them through the AI. So the rule could be, for example, I always want to schedule the bottleneck machines first. Or it could be that, well, I want to go in a sequence of meeting demand. First, I want to make items with the highest demand, meaning quantity, or maybe highest profitability, or maybe the ones that have the orders nearest in time. So order tomorrow is way more important than an order a month from now. Or maybe some very specific sort criteria as a result of combining these rules that you come up with. So these might be neither optimization nor simulation, but still intelligent enough for a system to then draw, run, and then make decisions off of, and then potentially over time use machine learning to improve the rule set as well. All right, so that gets us to our first poll. And we will open that up. The question here is, have you used any of these traditional AI techniques, whether it's optimization, simulation, rule-based, maybe all of the above, none of the above? The poll is designed that you can choose multiple answers. So we'll give you some minutes to vote on the poll. All right, so the winner is optimization. So most of you have, almost 50% of you have experience with optimization. Not surprising, optimization is probably the most commonly used from the traditional AI techniques. All right. Now let's focus on the world of the emerging, or some may call the already emerged AI. So there are three main areas I want to cover. The field is evolving at such a pace that this may already be outdated slide by the time I typed it up. But generally speaking, there's predictive, there's generative, and agentic AI. So let's go through all of them. Predictive, as the name suggests, tries to make predictions. So here is an example. If a bank is about ready to give me a loan, they might want to ask the question, hey, if I give the loan to this person, what are the chances of a default? Because obviously banks don't want to be in the business of getting the property as a foreclosed property and then go and sell. That's costs they don't want. They just want to give me the loan and they want me to pay it on time. So the question is, hey, if I give a loan to this person, what are the chances of a default? Well, a prediction-based AI, predictive AI engine can evaluate that based on characteristics like, I'm sure, income level and maybe family situation and maybe how many other properties someone owns and those types of things. They can say, okay, this person is a safe person to give a loan to, or maybe this person is someone you should never give a loan to, or maybe somewhere in the middle where you should give the loan to them, but give them at a slightly higher interest because there's more risk associated. So that may be a way to evaluate from a bank side. Criminal justice system similarly might be interested in the question, if I give bail to a particular person or send them on parole, will that be a good decision or bad? What are the chances of recurrence from that person? So these are things that companies, predictive AI's tools are already in use. If you look at the book, Snake Oil book that I mentioned earlier, some of these may be flagged as actually bad things, especially in the area of criminal justice. So anyway, just to give the example of a predictive AI. Now let's talk about it in the context of supply chain, which is where I guess the most interest is in this webinar. So if you look at this graphic from right to left, on the right-hand side, I have bad consequences. The bad consequences in a supply chain could be that I have some material that I have to throw away, scrap it, or I have to rework it to bring it within the norms. Maybe I have a contamination going on within my facility. Maybe I have some liability associated with the product that I ship to the customer. Now, if we come to the middle, there is a concern that leads to that consequence. The concern could be that a particular variable is out of spec, whatever that variable might be. And then if we go further to the left, there might be causes that make the variable go out of spec. The cause could be that equipment is out of order, operator is not trained, maybe the input material was bad quality, maybe there was problem with the utilities, maybe there's a problem in measurement. So all of these on the left are the causes that could cause a concern, and that concern in turn on some kind of a statistical basis can result in bad consequences. Not always, but sometimes. Now, this is a graphic that was developed by Dr. Nikki Villiers and Dr. Harpal Singh. Harpal is the ex-CEO of Arkiva, and they call this the bow tie analysis. So really, if we look at things in this cause, concern, consequence metric, then our question is, can we figure out this relationship and then avoid it? So that would mean that you can let an AI system run loose on this, and it'll figure out, it will predict that a particular equipment shortage results in a particular type of a side effect or bad effect X% of the time, and therefore it is worth tracking. Without the AI, we would guess at it. AI would drive it off of the data and give you the results rather fast. So here's some examples. If we have too many changeovers on a line, so let's say I have a chemical factory and I'm going from product A to product B to product C, and in a week, if I do one of those changeovers, no problem. Two, okay. Three, maybe it's dicey. But if we have 15 changeovers, well, the odds of that line breaking down go higher. So AI might evaluate that and flag it as a problem. Too many ships approaching a port, well, that would mean longer lead time. Again, AI can evaluate that and let you know that this is a problem. Too many next day orders could lead to trouble with the customers, leading to lower customer satisfaction. So these are just examples where rather than us theorizing, we can feed the data into AI, and if done well, AI should be able to find these relationships in the data. So now, since we are on the topic of predictive, in supply chain world, there is the prediction, a lot of the prediction is around demand planning. And so let's just look at some of the things that are out there, also with Arkiva software as well. There's a lot of AI-based forecasting methods. So the traditional time series-based methods they're good. They work in a wide variety of situations, but AI-based methods can add to it. There is no claim here that the AI methods will always be the best. They are just one more method, and sometimes they will give you a better solution than the older method. So you may want to use that as a part of the toolkit. Similarly, AI-based rule-driven forecasting. Then when it comes down to selecting the right method, we have the potential to use machine learning, where it can drive the forecast method and the parameter selection. You may use machine learning to drive the forecast pyramid, the hierarchy definition. I'll have a slide on that. You may want to use k-means and runs-based clustering. This is a way an AI technique can be used to figure out which demand items are similar, and they can be potentially forecasted together with similar types of methods. And then last but not the least, outlier removals. There's a great application of AI in finding out the outliers within your data. Let's look at the ML-driven forecast hierarchy. This is, by the way, something that is available in Arkiva, and I'm sure in other systems as well. The key question here is, if I want to improve the forecast accuracy at some level, let's call it material location level, how should I do my statistical forecast using all the methods that are available to me so that I get the best forecast? And you know, in the old days as consultant, we would try all the combinations. And when I say all, I say it loosely, because we would never be able to try all the combinations because there was limited time. So we would try a few based on some rules of thumb and come up with the best sequence of steps. The sequence of steps as represented by the numbers 4, 3, 2, 1. So you would start at the lowest level, number 4, and then do a forecast at the second level, one level up, and you would do that, maybe 2 levels, maybe 3 levels, maybe 4 levels, depending on the business, and always ask the question, is adding a level improving the accuracy? Well, with machine learning, you can do that automatic. You can just run the system. It will evaluate, depending on how many attributes you have, it will evaluate all the levels of your hierarchy, and it will tell you which sequence gives you the best possible forecast. Not just that, if you have divisions in your business, you have a business unit, you have countries, you have regions, it can generate different pyramids for different partitions of your business. So very powerful. All right, so predictive AI, again, it is dealing with prediction. Now, this is a line from the book. Predicting the future is not easy, and AI fundamentally does not change that. So let's be very clear about that. These techniques are good. They are one more arrow in the quiver. Will work sometime, will not work other times. Let's use it appropriately. Overall, as of today, I would say that they are okay, but not great. The predictive capability in some very unique cases can be very, very good, but in the case of supply chain, so far the score is okay, not great. All right, so let's do our second poll. Do you currently use or have experience with predictive AI in supply chain planning? All right, so roughly 50% said no, we are interested. We're happy to have a conversation about this in a subsequent, if you want to reach out. But let's move on to generative AI. As the name suggests, again, it generates. What does it generate? It generates text, it generates images, it generates video, and just in general content. And the principal model behind this is the large language models. These models have been trained on the abundance of data available on the internet. We'll not get into how appropriate that was, but the fact of the matter is that all these models have been trained on all the data. In fact, sometimes that leads to a problem as well. It's a relatively new tech, so there are errors with it. One of the well-known ones is hallucination, where it puts tries to find pattern where none exists, and it gives results that are, well, wrong. And then, of course, lately, AI is consuming AI-created data, which is not good and can lead to model collapse once in a while. I mean, there are techniques to, of course, handle this. So an example of that would be the video we ran earlier today. It is AI generated. If we put it out on the web and some other AI engine tries to learn from it, and if this goes on too much, then it can be a problem. In fact, one side effect of this could be that AI needs humans to generate good data so that it can learn from it, which is kind of interesting in the whole debate of whether AI will replace humans or not. Anyway, so let's just look at some examples. One example of language-based model is natural language processing, where we can take some unstructured feedback, convert it into structure, and then provide some sentiment score on it. So let me put this in real terms. If you have a website where you're selling items, you can ask the user, hey, on a scale of 1 to 5, did you like the experience? And the user scores it, let's say a 4, and you can evaluate that as 80% good. Well, that's called structured data. Unstructured data could be just provide a place for them to give a comment, and in that comment, they type whatever comes to their mind. It's in plain language. And so now you have to evaluate if that language is a positive language or a negative language. So there are techniques using natural language processing that will provide a sentiment score. And then once you have the score, you can sense which way that score is leaning and whether or not that will increase demand for your product or decrease demand for your product. So you can enrich your demand planning process using the sentiment analysis. And you can use this to eliminate or reduce surprises. So if you are in the CPG space, this might be an area to consider. Another area could be evaluation of plans. So we might have supply chain plans developed in numerical systems, whether it's optimization, whether it's simulation, whether it's rule-based, and we want to generate a summary to everyday supply chain questions. So it could be, for example, we can say, hey, based on the plan, where is the production growing? Which factory is running the hardest? Which demand is growing in which country? So you can interrogate the supply chain plan through interactive chats. When we say interactive chats, what we are saying is that the user is typing in plain language, English or what have you. The AI is interpreting it and then giving you the answers because it's able to convert your English into a query and then give you the answer. You could ask very pointed question. Hey, is there inventory for an item with this unexpected demand? Now you can do that today. You would have to know the tool. You would point and click and generate the report. But if you ask the question in the AI world, the AI will do the interpretation of plain language and then get you the answer. How about items with limited shelf life? Maybe we want to know if there are items with where the shelf life is about to expire within a certain duration, but we still have inventory, so that we can think about getting rid of them. So these are examples of things we can do with evaluating the plans. Then we can invest in creating language-based control towers. So for example, we could say, hey, what and how many new orders have come into the system today? What inventory can be decreased without impacting service levels? These are good supply chain questions. Today, you have to know the tool to get the answers, or maybe have an assistant. Well, AI can be that assistant for you. So you ask the question in English, and it generates the query in the background, and then you can get the results that way. So you can have language-based control towers run using generative AI. Similarly, very similar could be a language-based reporting. Show me a pie chart of sales by country by quarter. That's what you type. It evaluates that, creates the query in the background, and boom, you get the report. Show me a dashboard of demand and inventory data. Maybe it pulls up a dashboard that you have already saved. Maybe it's titled IBP Management Review. You issue the command, it pulls it up for you. There you have it. So a lot of different things can be done using this generative AI. And I would say, just to give it a score, I find it very promising. For the longest time in the world of software, that's where I come from, one of the main things that we are fighting is, are the users using the system? And so I find that this generative AI, if done well, it will help ease the burden of the users and help them understand the results of the models better, which then would mean that they would use the system more. So ease of use leads to more usage leads to more value. I have very high faith in all the users of supply chain planning system. When they use the systems, I always see they generate a lot more value. And for that reason, I score it very, very high. All right, so that gets us to our third poll. What's your most promising use case for generative AI in supply chain planning? Is it around writing or summarizing reports? Is it around natural language-based scenario modeling? Is it chat-style planning assistance? Or maybe you're not sure. So let's see how you vote on this one. All right, so this poll is much more spread out. About 40% said natural language-based scenario modeling, 22% said chat-style planning assistance, and 26% said we are not sure. So obviously, an area of growth with respect to how to use this. Okay, now let's talk about agentic AI. So the word agentic, of course, is derived from agent. Agent, as we think of, is someone who does something for us. So agentic AI is basically a class of artificial intelligence that works like an agent. It focuses on autonomous systems that can make decisions and they can perform tasks without human intervention. And in fact, today, they are maybe very limited to certain tasks, but then in the future, the hope is, actually, I would say, when it's limited to a particular task, it's actually called an AI agent. Agentic AI is more outcome driven. You let it loose on an outcome and it figures out 15 different ways of getting there. So agentic AI is a little bit more advanced than an AI agent, and it operates independently. It makes decisions through continuous learning and analysis of new and external data. It can utilize on an underlying basis, it can utilize very different techniques. It can utilize natural language processing, machine learning, computer vision, and depending on what you're trying to do, it can do a lot of different things. And in fact, it most closely resembles, if you know of a physical robot, this can be a software-based robot or a software agent. So let's look at some examples. Let's say we are interested in forecast improvement. Well, today, most of that is done using clicking a button and it will solve the forecast or generate the forecast for you. But if you had an agent, you could say, okay, I have a forecast, it's 63% accuracy. Well, I'm tasking you to improve the forecast accuracy. Use whatever you need to use. Here are some machine learning models. Here are some AI-based models. Here's some real-time sales data. Here is some external data like GDP and so on. And work in the background and report to me when you have improved the forecast, when you figured out how to improve the forecast. And that would be a good use of agentic AI. And by the way, I'm not saying such an agent exists, but I just want to use that to explain the concept. Now, here's one that actually does exist: autonomous sense and response. The idea here is that if you have a current supply plan that is including production, purchase, stock movement, you might want to let loose an agent which will analyze the plan in the background, evaluate against predefined metrics. So defined metrics could be profitability, carbon dioxide emissions, waste, a variety of different things. And it could evaluate and come up with a better plan. And as soon as it finds a plan that is better by a certain threshold percentage, it can flag it as a scenario. And then the user can say, yeah, I like this, I will use this going forward, or no, I don't like this. And so it creates the possibility of an automatic, autonomous supply response. So these types of agents are being made available. Even in Arqiva, we have an AI-enabled autonomous agent, which basically, just like I said, is evaluating and trying to come up with new scenarios, which improves the results based on the previously defined metrics that is shown in this graphic here. So this idea of autonomous sense and response can apply to other areas as well. You want to find a new supplier. Well, let the agent loose. You will have to configure it, of course, but once you let it loose and you set that as the outcome, it may look for many different characteristics and find you a brand new suppliers. You may say, hey, since COVID, I've learned that my lead times are becoming more unpredictable or less predictable. And so here's an agent whose job is to monitor how many ships are backed up at the ports, and based on that, change up the lead times up or down. Or I might want to have an agent figure out what is the best lane to ship product on given what is going on in the world, and it can evaluate and then suggest which shipping routes to use. Then one can use it in scenario planning. We can ask the agent, hey, run 5 scenarios. There's this thing going on called tariffs. You may have heard of it. So we want to say, hey, what if there's a lot of change? We don't know where it'll end up. Maybe it'll end up at 30%, 35%. I want to evaluate multiple scenarios for tariff impacts where the tariff is in the range of 25 to 50%. And so it runs those scenarios and reports back to you. Or you may say, run multiple scenarios in range of plus or minus 10% capacity. And as a result of running those scenarios, show me where the response surface look like. Now that's a new phrase that probably needs explaining. When we solve a particular plan, what we get is a point solution. So if you have multiple scenarios, many different scenarios solved, you will get multiple points and you can plot them on a graph, and that will then look like a surface. And so we call it the response surface. And the question here is, what does revenue picture look like? And it may simultaneously also be able to report to you that when the current operating assumptions just break and you may have to redo everything from scratch. So the agent can report that at what time the data conditions are so drastically different that the official scenario is irrelevant, and therefore you must regroup and replan. So let's score the agentic AI. I find it very promising. I see that people will bring out more and more agents. In the beginning, they will be for specific tasks. So they will be more like AI agents, and then eventually they will become more agentic. This will change the role of the supply planner. In my opinion, people will become what Gartner calls digital drivers. They will focus on things like business matters, like supplier collaboration and risk management and network redesign, and let a lot of the heavy lifting be done by the agentic AI. And certainly this has the potential to enable threshold-based autonomous planning. So because of those reasons, I score it very high, same as the generative AI. All right, so that gets us to our last poll for the day. How frequently do you run scenario planning exercises? Weekly or more, monthly or quarterly, only during major disruptions, rarely or not at all? All right, so the poll has closed and I'm surprised. One result is as expected, the other one is a little bit surprising. So more than half of you are running it weekly or quarterly combined, excuse me, monthly or quarterly. Combined it with the weekly, it's about 65%. So that's as expected. 23% have reported that they are not running scenario planning. In a webinar of supply chain folks, I am more than a little surprised to see that and would love to learn why there is no use for scenario planning in your business. I'll just generally say supply chain planning deals with future. Future is uncertain. No one knows exactly. I don't care what system you have, AI, non-AI, this, that. No one can predict the future. If we could predict the future, we would be in stock market, not in supply chain. So since we cannot, supply scenario planning is an effective way to deal with that uncertainty. So again, I'm perplexed that some folks don't do scenario planning, would love to learn why that is. Maybe their business is unique in many ways that I don't understand. Anyway, all right, so we have gone through the slides today and talk about the traditional, the emerging, and we divided the emerging into three areas: the predictive, the generative, and the agentic AI. What I would like to say in conclusion is that AI is here to stay. It will only get better as time goes on. Hopefully, it gets better in a way that the people who wrote that paper describe it, that it will at some point, just like digital, become part of our normal technology set, and we will just rely on it for some things and other things will go on as it is. In other words, some of the scary thoughts that people have out there about AI, it is my hope and wish that that doesn't materialize, but all the good things do materialize because that'll make life better. In the field of supply chain, there's a lot of promise with this tool. There's a lot of prediction. There's a lot of agents that will be built because supply chains can be labor intensive, so that will be helpful to people. And like any technology, don't focus too much on the math and the hype and everything else. Focus on business value. If you can drive it towards business value, it's absolutely worth it to use any tool available to you. If you think of AI as one of those tools, then you can easily drive real business value. And then, of course, hopefully that means it's personal value as well. On this graphic, we have a QR code on the top there. That's a paper on the Magic Quadrant that has been, that is the Gartner's Magic Quadrant. I highly recommend people to read that. And with that, I think we can conclude here and turn it over to Kristen to see if she has any questions that have come in.
Great, thank you, Sujit. That was really informative. We do have a few questions that have started to come in, so I will jump into them. And just as a reminder, if you have a question, you can submit it using the questions pane within the webinar platform. Okay, let's get started. Our first one is, in your view, when does AI go from helpful to harmful in the planning process?
Well, I mean, I think I would say, first of all, I would say read the book AI as a snake oil. I probably am murdering that title, but you know, the one I referred earlier, in that they have very clever examples of when it goes harmful. I think over-reliance, not focusing on business value, taking any prediction for as a given just because it came out of an AI tool, those are areas where it will really hurt us, and we should be really careful in the field of supply chain planning. Let me say it again. Supply chain planning is all about the future, as all planning is. Future is uncertain. There's no changing that. And predicting the future is just as difficult with AI as it is without. Just as difficult. Does not change. So because of that, it's the predictive pieces I would really caution about. Just because an AI tool says something does not make it a given. So that's how I would answer that, Kristen.
Okay, great. Let's see, this one is, can you share an example of how a planner's day-to-day workflow can change when AI is applied correctly?
Well, I don't know what they mean by correctly, but let's say if it is applied in a meaningful and helpful way, I can see that the time is freed up. If there will be automation of tasks that can be automated. Agents will do some things that the planner was doing till yesterday, let's call it. And so it should free up their time, and that should be a real boon to the planner, because ultimately the planners are hired to, or supply chain folks are hired to make the supply chain better, not necessarily be the collector of the data and running a process with 15 steps. So those things can be automated, and this can free up the supply chain folks to do more business value added tasks.
Okay, great. For companies just starting out, where's the best place to begin with AI in planning, forecasting, inventory, or automation?
Well, I think the field of forecasting is probably the most advanced, so I would start there. There's a lot more methods, there's a lot more agreement that those methods actually work in some cases. Again, I'm not saying they work like magic or they work in all the cases, but they work in all cases, and demand planning and forecasting is difficult for most people. So having more tools available to make that work, having a machine learning based tool to figure out what sequence of steps to run to make the forecast better, I would say those are the, I don't want to call them low hanging fruit, but maybe they are lower than some of the others. So that's where I would start.
Okay, great. Let's see, we have another question specific to our software. Can you give any details around how Arqiva is planning to implement AI in your software?
I think we are taking a multi-pronged approach. We have some of the forecasting methods I talked about. We have the machine learning based improvements to figure out the forecasting hierarchy that we have had for a while now, machine learning based. In fact, everything that I had on the demand slide, we have implemented some time ago. Then we have agents around sense and response that we have put in. We have integrated with language-based models to do language-based querying and summarizing of the plan. So practically all the things that I have discussed today are in some state or the other already in Arqiva, and that will just continue to grow, because that's where our focus is, to see how we can make the lives of our supply chain users better. And so whatever tool that we will evaluate as useful, we'll pull it in. Now, having said that, this is all around the so-called emerging AI. The traditional AI has been in Arqiva software for a long time, and if I don't know who asked the question, but if they are a user of Arqiva software, I would be really surprised if you're not using multiple of those traditional AI techniques in Arqiva. We have had that in Arqiva for 25, 30 years.
Okay, great. We do have time for one more, I think. This says, I agree with the use cases, but in terms of actually connecting our data streams to these AI agents, what are the baby steps small to medium-sized businesses could take?
Not sure if I understand the question. Connecting the data is the same as connecting data to any supply chain planning system. So yeah, I mean, we have to sit down and make a list of the things that would add to the AI thought process and then connect them. When you talk about connecting, there's a lot of technology available to make that connection, connectors and so on. And the thing that you have to keep in mind is The AI mindset could mean that you have to connect to internal sources, but at the same time, you have to think about connecting to external sources. And so you have to keep an open mind and then incorporate the connection that way. And very often, in the old paradigm, the connection was to move the data, but in the new paradigm, the connection could be that the data stays in the web, we just use it. So that might be a slightly changed way of thinking of integration.
Okay, great. Thank you. That is all the time we have today. So thank you everyone for joining us. We had some great questions coming in, and Sujit shared a lot of great information. So thanks again for spending some time with us today, and keep your eyes out for the next webinar. And we are also doing a LinkedIn Live on this same artificial intelligence topic. So if you'd like to get a little bit more information there, please join us for that as well.
Thank you.